Hi, welcome to episode 11 of Renewing the Conversation, a series of interviews where we talk to leading industry professionals and experts about renewable energy and heating, with a focus on the home and what challenges face the industry and homeowners.
Today we welcome Laura Bishop, Chair of the Ground Source Heat Pump Association. Laura explains the different types of ground source systems you can have and shares her thoughts on the new government grants coming out next year.
Before we get started, we want to say a huge thank you to today's sponsor, the MCS, which define, maintain and improve quality by certifying products and installers so homeowners can have confidence in the low carbon technology they invest in. To find out more, head over to www.mcscertified.com.
Don't forget to hit the subscribe button below and please show us your support by giving us a thumbs up. Enjoy the interview. Hi, good morning, Laura. Thank you so much for joining us today. It's an absolute pleasure to have you on the show. There's been an awful lot of talk about heat pumps and air source in the media recently, and I think that we're all becoming a bit more familiar about what that technology is. Can you tell us a little bit more about ground source and explain to us the difference and the role that it could play in homeowners and heating our homes?
Absolutely, yes. I'm glad to hear that you think that people are becoming a lot more familiar with heat pumps, because I think it's absolutely true. I think with it being in the media so much in the past week and actually in the past year, to be honest, people are more familiar than ever before with what a heat pump is and why we might need to switch over to using heat pumps in our homes and businesses. Heat pumps are an electrical heating system, and they use free energy that you can either find in the air or in ground or in water to bring that energy into the unit. We use a little bit of electricity, or as little as possible, to increase the temperature of that energy, so that you can then use it in heating, like your radiators, hot water, underfloor heating, different kinds of emitters like that. So air source is the simplest version of that, and most people have seen an air conditioning unit sitting outside office blocks. Many people actually nowadays will be seeing air source heat pumps popping up outside people's houses, and they take energy from the air. They're relatively cheap in terms of heat pumps to install and to buy, but the main downside of air source is that when you need the most heat, which is the middle of winter, it's when the air temperature is the coldest, so your efficiencies tend to reduce can be quite substantial in the winter time. This is where ground source comes in. So ground source uses energy from the ground, as the name would suggest. So there's two ways of extracting that heat energy. You can either have what's called a horizontal loop, where you have a large expanse of land and you dig down maybe about a metre and you lay lots of pipes in like a serpentine arrangement and you extract the heat that way. The alternative is vertical boreholes, where you bring a drill rig to site, and that actually drills down anywhere between 100 to 200 metres, which actually isn't that far in the grand scheme of things. It drills down and extracts the energy from the earth down at those levels. This is not fracking depths, and it's not geothermal depths. That's completely different. This is sort of shallow geothermal, we call it. And the great thing about this is that the ground temperature tends to be very stable all year round. So when you get down to a metre, actually, the temperature tends to stay very stable. And as you go further and further down, you're actually able to access much warmer temperatures. And that means that it doesn't matter whether it's the summer, autumn, winter or spring, you are getting pretty much similar efficiencies all year round, despite needing higher temperatures in your building in the winter time. And that's the main difference. The other thing about ground source is that you can also use water sources. So for example, if you are living in a housing development next to a big lake or a river or the sea, you can actually extract the heat from that as well, and that's actually a cheaper way of doing it. There's other things to think about there, but water is a great conductor of heat. It's got a lot of heat energy in it. So same technique, same heat pump, exactly the same heat pump. Instead of drilling into what we call a closed loop ground system, we're actually creating a loop within the water source as well. So very, very flexible ground source, very flexible and very efficient.
Wow, I hadn't actually appreciated that water source, and actually, throwing that into a lake or a pond or a river or a canal was actually classified under the ground source. So that's quite interesting. So with ground source, my understanding, as you said earlier on, is that there's kind of two fundamental ways of installing it. Either you do the slinkies, which is what you're saying, you kind of put
horizontal loops,
serpentine piping underground under your, whether it's a field or a park or that kind of area, garden. And then there's obviously the borehole where you go straight down. For the slinky route, that seems to me to be a real no-brainer for really large properties such as national trusts, palaces, manors, estates, where they've got really big parklands of just grass, and they can dig that up, put those slinkies in, and then cover it up with a lawn, and there you go. With regards to more domestic use and homes, what would be the kind of smallest property size or smallest land size that kind of application would work in?
Just on the slinky side, there is two types of horizontal collectors. You've got the slinky, and they're like lots of circles like that, and then you've got your serpentine, which actually just go up and down. So they are two different ways. The serpentine is actually a lot more efficient than the slinky, because the slinkies all touch one another, and so you get different heat transfer. So the two different types of horizontal. On the vertical boreholes, the actual borehole itself, so say for example you take a terraced row of houses, the borehole might, when it's finished, is actually probably only 6 or 7 inches in diameter, so they're pretty small diameters when they're finished. So you don't need a lot of footprint. So you could potentially fit a couple of boreholes in a small front garden, no problem. The thing that you've got to think about is that there's got to be access for a drill rig. So if you've got terraced houses that go onto a pavement and that the actual garden is at the back, you may not be able to get the drill rig into the back garden. That's the issue. Right. So the alternative would be then that you drill in the pavement, but then obviously you've got access and ownership of land. You've got to council. It's not a showstopper, but it's something certainly to think about. So borehole itself, really small footprint. You can have 2 boreholes relatively close together depending on the geology of the site, but the borehole itself is very small, and when it's finished, all you would see on the top is just a manhole cover. That's all you'd see. But it's the access for the drill rig that needs to be considered, and your installer would be able to give you information on that.
So are there still coils going down the borehole? I mean, what actually goes down into the borehole itself?
I wish I could draw you a picture. But basically, I'm going to try and demonstrate it with my hand. So if this was your ground level, they drill down and they drop what we call a U-bend in. So it's one pipe that goes down and back up. That's all it is. So it's got one single pipe that goes down and up. And then you've got the next borehole, and then that same pipe will go down and up, and then they'll join together at the top. What happens is the fluid comes down, the cool fluid comes down the hole, picks up the heat from the ground, and then when it comes out, it's actually warmer because it's picked up all the heat, and then that goes into your heat pump, rejects the heat into your house. That's how it's cooling down, and then it goes back down the borehole, picks up heat again, and it just goes around and around and around, keeps doing that. So it's not like a coil going down, it's just down and up.
With regards to costs, that's a big topic of conversation with regards to air source at the moment, and we've seen the government grants have confirmed that next year it's going to be £5,000 for air source heat pump. We haven't heard anything about grants potentially being available for ground source yet. Have you heard anything? And what kind of grant do you think would really help get homeowners, make ground source available to homeowners?
So the heat and building strategy that came out definitely said £5,000 for air source, and there's actually a £1,000 uplift if you want ground source. So you can have £6,000 if you want ground source. However, the cost of putting an air source heat pump in might be somewhere around the £8,000 to £9,000 mark, depending on the size of property, size of heat pump. The ground source is going to cost you around the £20,000 to £25,000 mark. So £1,000 uplift is not really cutting the mustard in terms of having a ground source heat pump. There are still a lot of people. We had our GSHPA AGM, bit of a mouthful, on Friday.
It certainly was.
It was a good opportunity to catch up with lots of our members who are regularly doing ground source, and some of them also do air source as well. And it's really interesting to hear from them about their customers. And some of their customers are still doing ground source without RHI. They're not bothered about this incentive at all. But they tend to be people who might have much bigger homes, they're quite wealthy, they might have rural estates with holiday cottages on, and barns and offices and outbuildings, and they're all going on to a ground source heat pump. And as I say, that the cost of the system isn't really of issue to them. especially if they're on oil. That's the thing. If they're on oil, obviously they can make they can make savings by using a ground source system. If you're just like me, just a normal homeowner living in a normal house in a normal city, then you may not want to spend £20,000 to £25,000 on a ground source heat pump. So what we're thinking there, what we're talking about, what we're discussing with BEIS is deploying ground source on a street by street or town by town basis. So rather than having, say, a line of houses, each having their own little ground source heat pump system going in, and each individual person paying for their own ground source, we're actually looking at and thinking about how this could work, where we have a shared borehole system, or a shared ground array we call it, that is then feeding each house. So a bit like having a gas main in your pavement where that's feeding multiple gas boilers. The homeowner doesn't pay for the gas main to go in. They don't pay for the gas main to come into their house. They pay for a boiler which gets stuck onto the end of the gas pipe. So we'd like to see that kind of thing happening with shared ground loops. So say, for example, there was major infrastructure upgrades happening. They were digging the road up to put fibre in, or a new water pipe or something. That's the ideal time to stick a new shared ground loop in that people can then connect a ground source heat pump onto. New build is the absolute best example of doing this. So when you're putting in anything from like a 10 house to a 500 house new development where a new gas main is being installed, that's the ideal time to put boreholes in with a shared ground loop as a heat network. So each house, instead of having its own gas boiler, has its own ground source heat pump. And social housing is another area. There's loads of good examples in the past and right now today happening where blocks of flats are having small ground source heat pumps fitted in each flat, and then they have a shared ground loop, which is the water out of the ground is distributed around the flats, and then each flat owner takes the heat off that. A bit like in London, where you have apartment blocks or other cities that are being connected onto heat networks, where you have a central plant somewhere like a gas combined heat and power plant or gas boilers. It's exactly the same thing, but instead you're using heat from the ground in your heat network instead of gas boiler heat in the heat network. There's nothing to stop any individual person having a ground source heat pump, but financially it's very difficult to make work. So therefore shared ground loops for normal homeowners, I say normal, just your average homeowner, I'd say, is probably the better way to go.
Yeah, it's really disappointing to hear that the government is only upped that grant by £1,000 for a ground source. That doesn't seem to be equitable at all in any way. So I think that needs a lot more discussion with the government. Hopefully there'll be more discussion and pressure put on during COP26 and going forward. Do you think that legislation is something that really needs to come into play, especially with regards to like new builds, and actually starting to really put more responsibility and onus on developers to really start to look at renewables seriously and invest in those into these homes? Because our biggest concern so far from our personal perspective of interviewing people more on the air source side is the cost of then all these new homeowners with these new homes having to then face retrofit costs later on down the line. Does that also apply for ground source, in the fact that, you know, retrofit is then well, obviously ground source in itself, originally installing it is going to be expensive, so then retrofitting it is then even more expensive. So do you think that legislation is something that really needs to come into play here?
Absolutely. And it's something I feel very strongly about. Whenever just where I live in Derby, there's several new housing developments going in. They're going in with gas mains, they're going in with gas boilers. They will then be locked in for several years. And if anybody then wants to take their boiler out and have a heat pump, it will probably be an air source because of the cost of the ground rate. So we're missing the opportunity right now today, 2021. We're supposedly in a climate emergency and have been for a couple of years, and yet we're still seeing hundreds, thousands of homes being built on the gas network. So what's happening is in 2025 we'll have the Future Home Standard coming in, and that will have new SAP which will treat ground source in such a way that it will be the Ground Source Heat Pump Association, we're trying to make sure that SAP treats ground source as the best, lowest carbon option. So developers will no longer be able to put a fossil fuel boiler into a house and achieve Future Home Standard level. So that's legislation that will come in. It's still 2025, so it's still 4 years away, which is still another 4 years worth of climate change. We found out last week, along with the heating building strategy, there's 3 consultations that have come out on the back of that. The first one is the phasing out of fossil fuel heating in homes off the gas grid. The second one is phasing out the installation of fossil fuel heating systems in businesses and public buildings off the gas grid. And then there's a market-based mechanism for low carbon heat consultation as well. So first two are really interesting for us for ground source. This is going to come into force quicker than the Future Home Standard. 2024 will be for large non-domestic buildings. So if after 2024, if a large non-domestic building, which is off the gas grid, tries to put in a new fossil fuel boiler, oil, LPG, they will not be able to do that. So therefore, they will have to think about doing something else. And then in 2026, the smaller non-domestic buildings, I don't know what the split, how they've defined large and small buildings, but after 2026, smaller non-domestic buildings will not be able to put in new oil or LPG boilers. Ground source is absolutely perfect for commercial buildings because a lot of them are on campuses where you've got multiple buildings attached to a single plant room, or they've got their own plant rooms and you could consolidate into one energy centre, for example, campus schools, prisons, hospitals, there's multiple buildings. And also if you need cooling as well, because of course ground source is great for cooling and heating and using the ground to store energy and to balance the ground. From 2024 onwards, we are likely to see an upturn in ground source interest. In fact, it should be before that, because if you wait till 2024, you've actually sort of run out of time if you suddenly need a new boiler. Yeah. So that's ideal. That's all legislation. The phasing out of fossil fuel heating homes off the gas grid, that's going to come in as well before the Future Home Standard. So again, more legislation that will make sure that different types of buildings are looking at renewable, low carbon options. And talking to Bays last week, they gave me a call because of being head of the trade association. I wanted to get our feedback on the strategy, and it's one of the things I've said in these two consultations. It's going to be a heat pump first option, so not necessarily ground source or air source, but just heat pump first. That'll be the first thing that these guys who own these buildings are going to have to look at. And we at the Ground Source Heat Pump Association, as of Friday, are going to come up with a couple of new working groups that are looking at ways of explaining this to the people who will be affected by these two consultations, putting these solutions forward and putting the proposal forward for ground source and how that can work, how that can be funded, the heating and cooling aspects, the heat network, the shared ground loop, all of those aspects over to these people. So again, it will be legislation. We've had 10 years of RHI. People haven't done it by now. That was the carrot. They're now going to get a stick from 2024 onwards. For me, it's not quick enough. But it's better than nothing, and it gives us a plan that we can work towards, which we were lacking before.
You mentioned there about cities and having to tackle heating in congested, built up cities. We've actually had it mentioned to us a few times, and it was only the first time that I actually seen it on the news. I saw it, I think it was on BBC or Sky News. It came up on one of their kind of PowerPoint presentations when they were just kind of explaining about air source, and it popped up and then disappeared again. And that was district heating. I think that that's something that a lot of people in the UK haven't really heard or are not very familiar with the term district heating. Where is ground source with regards to plugging into district heating, and how can district heating help alleviate some of these fossil fuel heavy burdened cities that are really relying on their fossil fuels? Where can district heating kind of slot in?
District heating in the UK has been around a long time, and a lot of apartment blocks, as I said, are attached to district heating schemes here. There's loads in London, there's a lot in Bristol, Manchester, Birmingham. So people may not actually be aware that these are actually going in. I spoke to a lady who owns a flat in Bristol. We were looking at doing a sewage heat recovery heat network for this block of flats, and she was talking to me about her boiler. What she actually meant was a heat interface unit. She didn't realise it wasn't a boiler, which is fine, because tenants shouldn't know. It shouldn't make any difference to them whether they've got a heat interface unit, an HIU, or whether they've got a boiler. So these are really common already. They're owned and operated by heat network operators, and the way they work is generally you have a central energy centre that houses a gas boiler, a gas combined heat and power plant, a heat pump that's generating the heat centrally and then discharging that heat into pipes which run all around the development. That might be blocks of flats going up risers and into each person's apartment. And the HIU is just a small box that sits on the wall. The heat from the heat network comes in and it goes through a couple of little heat exchangers inside. One does heating and one does hot water for your showers and taps. So that's completely normal, well understood in the industry. The average person on the street may not be aware of them. As I say, but they are happening, and they've been happening for a long time. The Green Heat Network Fund launches in April next year, and that's specifically for low carbon heat. So, for example, you may have an energy centre which has currently got gas boilers in. Take the gas boilers out or leave them as backup and put a heat pump in, and that could be a ground source heat pump, or it could be a large air source, or it could be a hybrid of the two. There's a job going in Cambridge at the moment called Swaff and Pryor, and that's a retrofit heat network job going in under the Heat Network Delivery Unit Fund. That is 330 existing houses of all different ages, ranging from like 1600s to modern day. And that's got a central energy centre with ground source heat pumps, some air source top up, and some electric boilers as well, going into a heat network which will heat all of those properties. So again, it's happening now. The alternative is the shared ground loop one, which I've described before. So again, we'd be drilling. You may have an apartment block being built with, I don't know, 200 flats in, and each flat would have a small heat interface unit. But instead of the heat being generated centrally with a gas boiler, it would actually be generated within the boreholes, and then the borehole water is pumped around the flats, and each person would then have either a small ground source heat pump inside their flat, or if it was being generated by a central heat pump, they'd have a small heat interface unit. We're seeing lots of examples actually of small versions of this popping up. So there's the North Aston estate in Oxfordshire. They've got 26 houses with HIUs and a central heat pump. I was talking to an installer on Friday who's just done, I think he said 5 or 6 properties off the gas grid, HIUs running off the central heat pump, ground source heat pump. This is where the market is edging, and it's certainly where the government want it to go with the heat networks, because they've said something like, I think 18% of all heat in the UK needs to come from a heat network by whatever the date is now, 2030 or whatever. And they've also got this Green Heat Network Fund, which again says heat pumps are the way to do this with low carbon heating. Built up areas, London, Manchester, Birmingham, all already using heat networks, and we'll just start hopefully to see more of them, but using heat pumps instead of gas.
We recently interviewed Bob Beattie, and he referenced a really fascinating project that he had worked on in, I think it was the 80s. Mm-hmm. And it was, I think it was the exhibition centre
Canary Wharf,
Canary Wharf, where they had actually installed ground source heating that had come from the Thames. And then he also referenced a couple of other projects that he'd been involved in where the ground source had come from the canals. And he said, it makes no sense. This country has got, hundreds of miles of canals, and a lot of those canals run through major cities, such as London, Manchester, Birmingham. They've all got these canals. And there's a lot of blocks of flats that are right next to these canals, and a lot of residential homes. So, ground source could potentially be installed and run through those canals. Is that something that you're seeing any kind of movement on? And do you think that will be part of the future of ground source?
Yeah, absolutely. I mean, in Birmingham, which is not far from where I'm from, you've got Gas Street Basin, you've got loads of new apartments that have gone up that back right onto the canal, and it seems ideal. You've got a water source and you've got a heat demand, so put the two together. The thing with canals is the thing with heat generation actually is it's related to flow, so you need a substantial amount of flow coming through to stop the waterway freezing up, basically. So if you try and suck too much heat out of a static body of water without rejecting any heat back, you will eventually find that the canal or the lake, whichever it is, will freeze up. So it's very, very important that you assess your heat demand against the flow that you've got available. And canals are notoriously very slow moving. You also have to drop pipes into the canal, so you have to be very careful about whether you're going to get boats mooring. Particularly in cities, you get a lot of boats mooring up. If you go down to Gas Street Basin in Birmingham, it's a big thing. You've got a load of boats everywhere, so you've got to be careful on a practical point of view from that way. There's different bodies involved, like the Canal and River Trust, I believe. They own and operate a lot of the canals, so you've got to be working alongside them, and you may have to also get the Environment Agency involved. Again, none of them showstoppers, but you've just got to watch all those different aspects coming together. Now, if you've got a cooling demand as well, you can be pulling heat out of the canal and rejecting heat back into the canal from the cooling. So if you've got an office block that needs heating and cooling, you can actually be rejecting and taking heat at the same time. So that actually balances the temperature in the canal. So yeah, in those instances, you might be able to use the canal for a much greater amount of heat and cool. If you've got a river, for example, middle of Bristol, you've got a river, quite a fast river, there's Severn running through the middle of Bristol, lots of buildings backing onto that. That's perfect because you've got lots of flow. You've got megawatts worth of heat running through a lot of our rivers in the middle of cities. So you mentioned the Thames. In Richmond, they've got a very large water source heat pump heating one of the Hilton hotels there in a big block of flats because you've got so much flow. Wow. You're very unlikely to freeze that. But then you've got issues to talk about to the Environment Agency. You've got to prevent fish and things swimming up the pipework and filtration and all that kind of thing. But yeah, it's something that is underused, underutilized, probably a little bit misunderstood. I still think we're in a position where, because gas is cheap and because most properties in city centres are on gas, there isn't the push to investigate these other sources of heat. So I've investigated quite a number of canal-based and river-based heat pump systems which haven't gone anywhere because the cost is not comparable with what they're doing at the moment with the gas boiler. Technically, as long as the design's done right, there's no reason why you can't use canals and rivers, but we need to see that push either from legislation or for gas prices going up or electricity prices coming down to make people think, yeah, actually, we should be investigating using these water sources for heating and cooling.
I'm curious from a hardware perspective. So we're quite familiar with an air source heat pump because we've had one for 3 years now. You know, you get a big block that basically goes out into your garden. With ground source, you're obviously drilling into the ground. Does that mean that the actual heat pump unit itself is a lot smaller? I assume it's still compressor driven. And can that just be housed inside the property, like let's say in the utility room near the hot water tank? Mm-hmm. From a hardware perspective, how does that differ from an air source heat pump?
The ground source heat pump unit itself will go inside. So if you've got a utility room, it can go in there. If you've got a garage, it can go in there. If you've got a lean-to or an old cold store, there's potential for it to stick it in there. Some people will have them in their airing cupboard, depending on obviously floor strength and the space and access and that. You still need a hot water cylinder. So in the smaller ground source, you may find that your cylinder and heat pump are actually combined in one box. I see lots of heat pumps and I expect lots of heat pumps. They look a bit like a fridge freezer, that kind of size, that kind of footprint. Some of them are just the heat pump with two compressors, depending on the size. Some of them are a heat pump at the bottom or on the top with a cylinder, all combined. So that's what you'd have inside your house. So you definitely need space for that. In small blocks of flats, there are shoebox heat pumps, which are tiny little things which can fit under, in a kitchen cupboard or something like that. We still need to find room for the hot water cylinder or the heater battery for that. So that's the difference. Outside, all you'd see is a manhole. Inside is where you'd see all the hardware, and it's not huge depending on the size of the house.
So you've got the coil system that you can basically do for ground source or the actual drilling down the boreholes. Is there a big difference between the efficiencies between the two? So is the borehole one more efficient than the coils?
There is a slight increase in efficiency because you are going down to depths where the earth it's not hot. It's not like the center of the earth hot, but it's warmer. So you are consistently getting warmer temperatures out of the ground at that depth. Whereas the 1 meter down, it's still going to be a constant temperature, but you're not getting the benefit of going down deep and getting warmer temperatures out of the ground. So there's a slight efficiency increase. The main benefit really is the space. So if you don't have the big space for a big horizontal collector, you have to go down. And then you also get a slight increase in efficiency as well.
And what kind of maintenance requirements do you have then? Are the maintenance requirements different for the actual coils versus the borehole?
So you shouldn't, once the borehole or horizontal collector is in, you shouldn't ever need to dig it up, access it or anything like that. You will have a manifold chamber, which is why you've got a manhole. So you can lift the manhole, check the manifold chamber, check all the valves look okay, everything's, nothing's corroded, nothing's leaking. And there will be, just like with your gas boiler, you might have somebody come in once a year, check everything over, balance everything up again, fill up your magnetic filter, empty your magnetic filter or fill up your dosing. Exactly the same for a heat pump. It's not fit and forget, just like your boiler is not fit and forget. You would need an engineer to come out once a year really and just check everything over, check it's all okay, and they will probably do that as a package. So if you're a domestic user, if you had a gas boiler fitted, the fitter may offer you an ongoing maintenance package that you pay for monthly, annually. Exactly the same for a heat pump. The installer will probably, or you should ask them if they don't offer, do they do an ongoing O&M maintenance package that they then come in for £100-200 a year, whatever it is, to check everything over. But you will never, unless anything goes catastrophically wrong, you wouldn't need to dig up your ground loop. And if it was a borehole, that's all grouted in, so you wouldn't be able to do that anyway. But you shouldn't need to. It should be there for 100 years with no leaks. It's plastic pipe, shouldn't be an issue at all.
So for horizontal ground loop, it needs a fair amount of space to go in. Obviously, it is dependent and relative to the property that it's going to be heating. But once you've put that in and you've put the lawn over the top, what can you do with that land? Are you allowed to plant, shrubs and trees, orchards? Are you allowed to plant anything on that, or do you really just need to keep it as grass and lawn?
No, you can, depending on the depth. We've got a job at the moment in agricultural college. Horizontal loops, they plough the field. So that field is an agricultural field for growing crops, and we've had to go down deeper so that the plough doesn't obviously rip up the pipes, but they will turn that back into an agricultural field. You can grow trees on it, you can grow your shrubs on it, you can put a tennis court on it, whatever you want. You may find that, depending on how well it's been designed, you may see, for example, I've been out to sites where I've seen, as like on a snowy day, and you've got melted patches because the ground's warm, or you've got more snow in one area because the ground's cold. You may see that, but in terms of reusing the land, once it's in. You just need access to those manhole covers and make sure that you don't dig down so deep that just like any ground service, like a gas pipe or a water pipe, you don't want to be sticking your spade through it.
So we've heard about the brands that are kind of associated with heat pumps. What are the brands that homeowners should be looking at, or what are the most reputable companies out there that deal with ground source that people should be going to, and how can they find them? Do they just kind of go to MCS and ask for a list of approved ground source, or where do you begin if you're a homeowner?
Okay, there's loads of really good ground source heat pumps on the market for domestic consumers, and many installers will be affiliated with one or two of those, so they understand that heat pump very well. Best place to start is with one of the associations. So the Ground Source Heat Pump Association has a list of members. There's installer members, there's consultant members, there's drilling members, and supplier members. So go to the Ground Source Heat Pump Association website. That has the list of members, and you can search by different types of installers. You can search by where you are in the country and have a chat to them. The fact that they've decided to become a member means that they care about what they're doing, and we also run checks, and we're here in the background checking that they are doing what they should be doing. MCS is another good place to start, because you need to be MCS registered if you are going to do any kind of government incentive installs. And MCS is really important, because if you have any problem with your system after it's gone in, that you've got some comeback on MCS, you've got some protection there. And then the last thing I'd say is, if you know anybody who's had a heat pump, ask them. So word of mouth, who's good, who's bad, don't touch with a barge pole. Those are the sorts of places. So start with the trade associations and then work your way along from there.
Absolutely. Renewables are a very exciting space. And I think that, as you said, yes, okay, ground source is more expensive at this moment, but you are seeing a demand there. And I think that, as you mentioned, with, canals, and there are so many areas where ground source there's still so much innovation that can happen in ground source, and that we're going to see develop over the years. What are you most excited about with ground source? What really kind of gets you going in the mornings and you think, okay, this sounds really cool for us going forward?
I think the biggest thing for me, I mean, my background is designing big commercial heat pump systems. So, like I mentioned about campus schools and campus buildings with heat networks. What gets me out of bed in the morning is customers who come and say, I've got this big building, I've got this big factory, we want to decarbonise, I don't know what to do. And you can go in and you can look at it as an engineer and just say, right, you need to have a shared ground loop, and you need to have individual heat pumps, and some of them will be heating and cooling, and some of them will just be heating only. Or actually, we need to put in a central energy centre and run some heat mains, and then you need like a couple of little remote air source in the smaller buildings, something like that. That's the really exciting bit, and people are so enthusiastic about getting rid of their oil, LPG and gas. Some people. That's so good. And I just think that will continue, particularly with the consultation on the off-gas grid buildings. But that's purely from my point of view, because that's what I work on all the time, and that's what I absolutely love doing. You've got the multiple houses going on to share ground loops, and how that actually works. How do you make the investment in the ground side of things, in the infrastructure? How are we going to make that happen? How are we going to make it so easy for somebody to come to the end of their gas boiler's life, and instead of saying, right, ring up, get a new gas boiler, how do we make it so that they instantly go, well, actually, I won't do that. I'll get a new ground source because there's a ground loop that's been put out outside my house, in my pavement, and I want to connect onto that. So that's also, it's all these things that we're ready. We have all the ideas, and not just the ideas, but the ability and the technology to help us do it. Bearing in mind in Europe, this has been going on for years and years. It's completely normal. We can just bring that in to the UK, and in fact it's already happening and has been happening for a fair few years.
Do you think that the general public, do you think that we're all going to start to move into a completely different era of the way that we think about heating our homes? Because it's been so interesting just from our perspective. I know that you're obviously in the industry, so you might see things more introvert, but from an external viewpoint, it's just been really interesting that when we were looking at moving house and purchasing this house, it was just kind of gas boilers, and nobody was really talking about how your heating works, what your heating is, where's it coming from. And now suddenly everybody's acutely aware of their electricity tariffs, of, what if they need to change their radiators, what they're talking about insulation, they're talking about where is their gas coming from, what is their impact on carbon. And so I think that it's really interesting to see almost like this mind shift in people becoming suddenly, families over the dinner table are talking about heating, which isn't a normal conversation for people to be having. And then you've got, the recent energy crisis ongoing, and these, this winter that families are facing. Do you think that we're now reaching that point where families and homeowners, it starts to become more top of mind?
I think there's a real split. I think there are some people who will do exactly that, and they will be thinking about the way their heat pump operates, and thinking about the way they run their heating, when they run their heating. And there's always been people like that, actually. So I know some people who will every day, they'll have a look at their smart meter and write down how much electricity have I used today, how much gas have I used today, or how has my heat pump performed, or how has my solar PV array performed today. There's always going to be those people, and I think there are more of them, but I don't think yet it's got into the masses. So I think about my friends, they know I work in heat pumps. There's a couple of them that are interested and will ask me specific questions, but majority of them, heating wouldn't even probably come into their day-to-day vocabulary. They wouldn't have this conversation. So I think we will see it happening more and more. It doesn't mean that heat pumps won't work. I think back to, I was born in the 70s, and when I was growing up, we had storage heaters upstairs, and we had a back boiler running off the gas fire downstairs and some radiators. And back then in the 70s and early 80s, that was completely normal. And then we suddenly got boilers, and we suddenly got radiators and central heating, and it just happened. And actually, that's what I'd rather see, is that we are able to produce a solution for the majority of homeowners where it makes absolute sense that when they come to replace a gas boiler, for example, you wouldn't replace a back boiler with another back boiler. Generally, you'd replace it then with a boiler, a central combination of condensing boiler. We need to make it so that that's the standard thing to do without even thinking about it. You just go
more of an evolution.
Yeah. So like going from coal-fired heating with no central heating to a gas back boiler. Next phase is a heat pump. So I think that will happen anyway. You're always going to get those people who are super interested in the way everything's working, and they're brilliant to chat to. But I think a lot of people will just have it and not even probably consider it because it's become so normal. That's where we need to be, I think.
Well, thank you so much, Laura. I have learned so much more about ground source. Some of it was a bit of a light bulb moment, I'll be honest. And I don't know, I'm going to be very intrigued. I think that this time next year, I'm going to ask you if you're going to more dinner parties and you're becoming more of a target of conversation. I think you're going to start to feel that people are gravitating towards you. So let's come back to you a year from now and ask you, and we'll see if there's any mind shift. I'm hoping so. But thank you so much. It's been such
Laura.
a pleasure.
No problem. Thank you.
Take care. Bye-bye.
Bye.